In case you're just joining me, this series looks at the engineering problems faced converting this Pinzgauer 712M to an electric drivetrain. In this video, I dive into how I used CAD to prototype, get 3D prints made, and then have the part machined for the new front mount for the electric motor. For context, I needed to make a new mount because, for reasons explained in previous videos, the motor went from being mounted way down here to being mounted way up here. So this is the state of the CAD project when I had to take over. A few things to notice. First, the rear mount was modified with respect to the old motor position, so the motor isn't shown raised or rotated, and of course this means that it doesn't play nicely with the scan of the underbody, and I don't have a good starting place for the bolt holes on the back of the motor. So first I'm going to need to get this motor in the right place. Note that over here on the left, Onshape keeps track of every single change that is made, so when I select a change over here, I'm jumping forward to the state of the CAD project at that change. So in this case, I'm jumping forward like 16 changes, and that's how I'll be taking you through how I did this. Alright, so first I raised the rear motor mount 63mm to match reality, and now it looks like it mates correctly with the underbody scan. And in the next change, I've raised the motor 63mm and rotated it 45 degrees. You can see that the front mount, which is kind of behind everything here, isn't yet modified. And now I've started modifying that front mount. I was brand new to Onshape and modern CAD in general, so I didn't really know how to approach this. I'm actually something like 8 hours into the learning process here, and I was just proud to have managed to expand the part to at least cover the new position of the mounting holes. That initial learning curve was brutal. Here, I'm just starting to outline thoughts on where the holes in the part will be, and the new edges of the part. I've started learning about constraints by this point, so the holes I'm creating are constrained to have their center point coincident with the bolts, which are already constrained to a certain spot on the motor. These gray lines have constraints like start at this point over there, and intersect with this circle over here, and be tangent with it. As it turns out, these constraints are incredibly powerful. It means that if I construct them well, later, I'll be able to just move this bolt and all the constraints will update and adjust the part to accommodate. And now I've figured out how to start removing material using the extrude tool, and I'm adding some more detail to the shape. At this point, I'm close to being able to get my first prototype printed. I've added some standoffs for the mounting holes and trimmed all the excess material. One thing that I'm not super happy about is that this front mount doesn't line up with the scan of the underbody very well, but the rear mount and motor do. So let's address that. I'm going to actually move this assembly of parts, the front motor mount, the shelf, and the inverter. Now this is really interesting. I hadn't noticed at this point, but because I had done my constraints well, you'll see that the front motor mount actually deforms to accommodate its new position with respect to the bolts on the back of the motor. I'd expected to need to mess around with the part a bunch more, but when I went back to look at it, all the mounting holes were in the right place. I was confused, but happy. I discovered later how to actually do this on purpose. Anyway, it was time to get a prototype made. I used the same guy for the first print as I did for the rear mount, and I had a part in no time. As you can see, it wasn't a great fit, but that's what's nice about 3D printing. You can iterate cheaply.
So I marked, okay, I need to move it 5.5 millimeters in this way, and I need to do 2.2 millimeters that way. Need to move that there. Just marked it up. Also noticed that I was too close to one of the lines.
So I made these modifications here, adding a circular cutout for the coolant line, and finally using my new skill of moving that bolt and allowing the constraints to rework the part. You can see on the left how few changes are required to make this happen. Basically, you drag the bolt over and you can see the new location of the bolt is defined, but the part isn't yet updated. And then tell the part to use the new context for that bolt. And if you had your constraints right, the hole will snap its new center to the bolt's new center. All those tangent lines will realign with where the new hole is, and the part reconfigures itself. So time to get the second prototype made. Since the original builder wasn't available to help anymore, I wanted to find another way to get these parts printed other than his contact, so I tried CraftCloud. It was pretty easy. I just exported a step file, uploaded it, and got some bids. I selected a company that seemed reputable, and $90, and about a week later, I had a part at my house. I'll sneak in a reminder here to like and subscribe if you want to make sure to see the next video in this series. And it fit really well. Just a few minor adjustments and some finishing touches were needed. For example, as you can see, I'm smoothing out this cutout for the coolant line, and I still needed to move the bolts just a tiny bit and change some of the mounting face offsets, but by now I was pretty decent at this, and I was pretty sure that it was only a matter of time before I had exactly the part I wanted and a well-mounted motor on my truck. So at this point, I'm just doing some last-minute sanity checks on verification, making sure that these still look good against the underbody scan, chamfering to remove sharp edges, but we were ready to test what I expected would be the final print.
And the finishing touches was like my third print here, and that matches the part that I finally had machined in aluminum. So that was kind of my iterative design process.
Each of these parts cost me around $50 to $90 to have made, and yeah, that saved me a lot of money not needing to shell out the cost of machining and anodizing, and plus it's a lot faster. For what it's worth, I was quoted $460 for the machining and anodizing, plus a 30% tariff and $100 shipping from a Chinese manufacturer that the previous builder was using. But of course I opted to use my friend, whose family runs a machine shop in the UK, and who I still need to figure out how to force to take my money. I think he might want to get paid in tea or something. Anyway, here's a picture of the part installed, and if you follow the recommended video that should be on screen now, you'll get taken to the video where I actually use this part on my truck.